Okay, so now we're working on 1015. This is about SAT scores, and they give us a mean and a standard deviation. So we're supposed to construct a 95% confidence interval. So to do that, we needed to use our inference toolbox in all four steps. The first step is the parameters. So our parameters, first of all, our population. The population in this case are high school students that take the SAT a second time. And then the parameter that we're looking at is the mean score gain. Now we need to check our three conclusions. There are three conclusions that we need to check. First is it a simple random sample? In this case, yes, it is. Is it normal? It is. It says in the problem that it's normally distributed. And independence. In other words, are there more than 10%? Basically, are we sampling no more than 10% of the actual population? Well, in this case, our sample size is 1,000. I'm sure there are more than 1,000 students that are taking there's more than 10,000 students taking the SAT a second time. So that is true as well. So all three conclusions are there. So now the next step then is to actually do our calculation. The formula for the calculation, we start with and it's plus or minus our critical value times the standard deviation all over the square root of n. That's our formula. So in this case, our x bar is, actually let me rewrite that for the x bar being 22 plus or minus our critical value, since we want a 95% confidence interval or confidence level, we want 1.96. And then we're going to take the standard deviation, which is 50. They told us sigma, and over the square root of 1,000. So when we calculate this, we get an interval that goes from 18.9 to 25.1. Last step is to interpret. So in this case, I would write out with 95% confidence, we estimate gain for all SAT math second time scores to be between 18.9 and 25.1 points. So that's part A. Part B, they ask you to calculate the 90% and 99% confidence intervals. To do that, remember, it's the same thing. We're just going to do, let's say for 90%, we're going to do 22 plus or minus. For 99, it is 1.96 times. And for 99%, we're going to do 22 plus or minus 2.576 times 50 over the square root of 1,000. And when we do that, we end up as our answer to be, for 90, 19.4 to 24.6. And for 99, 17.93 to 26.07. Now, for part C, they want us to make a sketch that shows all three intervals. So when we do this, I have my number line here, and 22, and then we've got, let's do 21, 20, 19, 18, go further down, 17, 23, 24, 25, and then I need to extend this down to 26 and 27. So I'm going to use, the first one is going to be in blue. That's the first one we found. That goes from 18.9 to 25.1. That goes right here. Okay. I should use a thicker one. Let me draw that again. Okay, so there's that's 95. With 90%, we can do 19.4 to 24.6. Oh, let's do that in a different color. Let's do that in green. And then I'm going to do the 99% accuracy. And 17.93 to 26.07. So as you notice, the more confident we are, the wider our interval. And that's the question they want. That's what they wanted you to answer for part C.